SO3 is the group of rotations in 3 dimensions. So the defining representation would be in terms of 3 by 3 matrices. Let's call them R. So orthogonal 3 by 3 matrices with unit determinant actually, which we think of as acting on vectors in R2, just multiplying them, transforming them to some Rx. What did I say? R2? R3. In R3. Okay, so what would such an R look like? For example, we could think about a rotation by an angle phi about the z-axis. We could write this in terms of this rotation matrix here. And now if you want to go to the Lie algebra, we take the derivative. So we say the generator of these rotations, that's minus I derivative of Rz with respect to phi at phi equals 0. So we have a minus I here, and now derivatives of this cosine are minus signs, and at 0 we get 0. So we have zeros here. We also have a 0 here on the lower diagonal, because there was just something constant. We have zeros where we had zeros before, and now the derivative of the sine is the cosine, and at 0 that's 1, and up here from the minus sign we get a minus 1. So together with this minus I convention we have 0, I, 0, minus I, 0, 0, 0, 0, 0. So this would be the generator for these rotations, or we could say it's an element of the Lie algebra, little SO3. The Lie algebra SO3 of the Lie group SO3. And maybe we would want to use not X, Y, Z as labels. Sometimes we would want to use 1, 2, 3. So we would also call this one here J3. Now you can do essentially the same thing for rotations about X and Y axis, and then you find these generators here. And now by really just multiplying matrices, you would find that, for example, the commutator of J1 and J2, matrix commutator, that's just taking J1, J2 minus J2, J1, that's in the end just minus I, J3. And similarly for the others. So if you've never seen this, check this for one pair. And so in general you find, let's say, Jj and Jk commutator is equal to minus I sum over, let's say, L from 1 to 3 epsilon JKL, that's the totally antisymmetric epsilon JL here. So here we have the structure constants, or actually without the I, define this. So the minus epsilon would be the structure constants of SO3. Minus epsilon. And the epsilon, just for reference, is this totally antisymmetric thing here. So it's 1 if JKL are in cyclic order, and it's 0 if, let's say, at least 2 indices are the same. And minus 1 otherwise.